Alright, so we have a FRQ here for AP Microeconomics. Um, let's begin. So the table shows Theresa's marginal utility for bagels and cars. What is her total utility from 3 cars? Alright, so let's look at 3 toy cars. And so we have these marginal utilities here. So how much each car gives her. And so if the first car gives her 10, the second car gives 8, and the third car gives 6. This will be a total of 18 plus 6 is 24. 24. So 24 utils, just whatever unit of satisfaction here. Let's see here. The weekly income is 11 and the price of a bagel is 2. So I'm just going to write 2. And the price of a toy car is 1. Okay. So let's figure out basically the utility per dollar. Okay, so I'm going to write the utility per dollar here. So this is 3.5, 3, 2.5, 2, and 1.5. So now these are basically on level playing fields, if you will. So you can kind of compare these. So you have $11, and so you're going to start buying the thing that gives you the most utility. So this is 10, the $10 toy car. So I'm just going to keep a tally of how many dollars we spent. So we got the first toy car. Cool. And so next we're going to look at whatever gives us the next most satisfaction. So it's either 4 per dollar or 8 per dollar. So we're going to buy a second toy car. So we've now spent $2. And then we have 6 versus 4. We're going to buy this one that does 6 first. And now we have 4 and 4. But we have enough money to buy both of them. So we're going to buy both the next toy car and the bagel. So we buy $1 for the toy car and then $2 for the bagel. So next we have 3.5. So we're going to buy that second bagel, and again it's $2. And then we have 3 versus 3.5. So, or 3 versus 3 here. So we're going to actually buy both of these. And so we're going to spend $1, $2, $3. Oh, hey, this is 11. We're out of money, so we're going to stop. So we're going to purchase 5 toy cars, 5 toy cars, and 3 bagels. Okay, and so it says, explain your answer using marginal analysis. So we are at the point where the marginal utility of the toy cars over the price is equal to the marginal utility over the price of bagels. So if you look here, we have the marginal utility over price and the marginal utility over price is both 3. So you could just say that these values are equal. The marginal utility of bagels, I'm not going to write it out. Can I change the color? So the marginal utility of bagels is equal to the marginal utility of toy cars. And if you wanted to do some algebra to solve for some value, you would have the marginal utility of A over the price of A, and assume they are maximizing their utility here, then marginal utility of B over the price of B. So this is if they are maximizing their utility. All right. Let's see. Assume that the price of wheat is an input for bagels, and that increases. So bagels will make the the increase in price of wheat will increase the supply curve or decrease the supply curve. So because wheat is an input, there is less input, so the supply curve is decreased. There's a decrease in supply and not demand. So the demand will not change, but there will be a decrease in quantity demanded because of the shift in supply curve, not a change in demand. And the question asks change in demand here. So you could say demand will not change because the supply and not the demand for bagels. Something like that. Let's see. Suppose that there is an income elasticity of -2. So income elasticity is not really from this unit, but it's still good to remember because it's the end of the semester. So income elasticity is related to inferior versus normal goods. So you already know that it's not going to be a substitute or a complement. And if it's a negative, it is an inferior good. And there's really no explanation, so I'm glad it's not say explained. It's just the income is negative, so it's inferior. All right. Suppose the price of toy cars increases by 10%. Teresa buys 5% fewer toy cars and 4% less toy blocks. Calculate the cross price elasticity of demand. So this is where the substitutes and complements idea comes in. So the cross price elasticity of demand. So the income elasticity is the percent change, so percent change in quantity demanded over the percent change in price. So if this is good A, then this is good B. And so whichever information you have will dictate whichever is which. So let's see. So when the price increases by 10%, they decrease by 4% toy cars and 4% less toy blocks. So we don't want toy cars and toy cars because they are cross price, so they are not the same thing. And the only one we have for the price is the toy cars. So we're going to do this 10% for this change in price here. And so if this is good B, toy cars is good B here. And so we're not going to look at this 5% fewer toy cars. We're going to look at the 4% less of a different toy. So because it's negative, or it's less, it's a negative. So, and this is 4%. So 0.04 divided by 0.10, let's see, that is equal to negative 0.4. And that is all for this question. Alright, so here's another question. We have Sasha as a utility maximizing customer who spends all of her income on bananas and peanuts, both of which are normal goods, so that might come into play later. So, total utility of some of the lost unit of peanuts consumed increased the total utility from 40 to 48 and the lost unit of bananas. So I'm just going to write the peanuts and we're going to just notate there's going to be an 8. And with the bananas, that is 4. So we're not really doing anything there, we're just kind of notating this difference here. So if the price is 1 for peanuts, calculate the price of a unit of bananas. So because she is utility maximizing, we could use the idea of the marginal utility of, let's do it up here, marginal utility of A over over price of A. I'm getting too excited about economics here. That's going to be the marginal utility of B over the price of B. So now we can just start substituting in numbers. So we have the marginal utility of peanuts because we increased here. So this is 8. Ooh, that's like a fancy pen. Let's not do that. I mean, that's pretty cool, but we don't need that. So 8 over the price of peanuts, which is 1, which is going to be equal to the marginal utility of bananas, which is 4, over the price of bananas. So we can just write P. And so now we can do some simple algebra saying 8P is equal to 4 and P is equal to 4 over 8 or 0.5, and this is dollars, and so let's put dollars, and so this is, we can box this. So this is that question. Okay. So if the price of peanuts increases and the price of bananas remains unchanged, how will she how they change how much she purchases peanuts? So because she is currently utility maximizing, right? Um, we don't really have to really think too much about like how it'll affect it or whatever. It's just these the price of peanuts increases, and she is a and peanuts are a normal good for her, so she's gonna have less r- technically real income, right? Um, she can spend effectively less money on her peanuts and technically bananas because she will buy less of both because of the income effect. That is basically what that says. And so she will buy fewer. So less peanuts. I'm just gonna write less p. Um, let's see. So assume that the cross price elasticity of demand is positive. That means these two goods are substitutes. If you see the price in, for example, if chicken and meat, or if chicken and beef are substitutes, and you see the price in chicken goes up, then you'll go over to beef and be like, yeah, I'm gonna buy more of that. That is what that's saying there in that context. But a widespread disease has um, destroyed the banana crop. That is not good. So because you have less bananas, right? They You may not have the ability to buy them as much. And so the price and quantity of peanuts will increase because they are substitutes. Uh, because the price of one increases, the other will increase. Just based on the fact they are substitutes. So increase P and Q increase. This is definitely not going to get full points, but you'd write price and quantity increased um, of peanuts because they are substitutes. And because the bananas price increased because there's less of them. Um, the demand for peanuts would increase, which in turn increases the price and quantity. So let's look at part C. I'm not going to write all of that. The substitution effect. It Let's see. The price of bananas increases. That's quite sad. Bananas are pretty good. But the substitution effect says that when you have an increase in the price of a thing, you will buy less of that thing and more of another thing, another substitute good, because it's more expensive. If chicken and beef are substitutes and the price of chicken increases, I don't want to buy chicken anymore. Beef sounds a bit better. So it's going to decrease. All right, and we were talking about this earlier. The real income, you will buy both less of the bananas and peanuts because you effectively have effectively less money. The real income will decrease. You have, I cannot think and write at the same time. That looks like Q. Decrease. You have effectively less purchasing power. The money that you have goes not as far. You cannot buy as many bananas, and because you spent more money on your lesser bananas, you will also spend less money on, um, or you will also buy less peanuts. So the real income decreases. All right, we are going to do one more for response. So the table above gives the short run marginal product of the labor curve for a perfectly competitive firm with the first kind of selling product for $5. Calculate the marginal product. Okay, so let's see. We want the third worker. So we know that the marginal revenue product, MRP, is equal to the marginal price, or marginal product times the price of whatever that is. And so this just becomes an algebra problem now that we know this is the third worker, and it is for the marginal revenue product is $450, and we define the marginal product. So this is just some number, so I'm just going to call it product. Actually, P is not good. I guess I'll leave it at MP. And we also have the price. The price is $5. So we could just divide this side by 5, and that's the marginal product. And so 45 divided by 5 is 9, so this is 90 labor units. Or wait, the table for label 90 does not say, just 90 units of whatever the output is. So 90, let's put units, just to make sure they know I know my units. Alright, define the law of diminishing marginal returns. This is an interesting question. I am not going to write all of this out, but I will gladly explain it. So, the law of diminishing marginal returns says that if you have some limited number of resources, that it will slowly make less and less output. For example, if you have a farm and you have one tractor and a bunch of people are working on this farm, but they have to take turns for the tractor, the more people you hire is not going to do too much. Like after like the 10th worker, you're barely going to be making any more output because you're all just waiting for the one tractor. So basically, the more inputs that you have, the output will still increase, but it is increasing at a decreasing rate. You're getting less output for each additional input. And so, and it occurs because of the overuse of the fixed input. If you have too much fixed input, then you don't have you can't generate increasing output. You have a limited number. Okay, so the diminishing marginal returns first occur with hiring. Let's see. So we start noticing that the price here, or the revenue product, goes down here at the start worker. So, and that's where the uh, diminishing marginal returns kind of kicks in, if you will. So this is worker 3, worker, can I write an R? Worker 3. Okay. What is the highest daily wage that they would be willing to pay to the fifth worker? So people think at the margins they will pay up to whatever they make. So for the fifth worker, it'll be this $300. So it's not $299.99. It is. We're just going to assume that it is $300. You think at the margins, you will pay them however much they give you back. That is the absolute maximum. So this is $300. 300. Okay. What will happen to the demand for labor if the market price of the product increases? Um, so the demand for labor if the price of the product increases. Well, this is marginal revenue product equals marginal product times price. There's so many. If there's a free response question on this, you will almost always have maybe 1 or even 2 points, or even more sometimes. And this is bound to be some multiple choice questions. Just this kind of knowing your basic formulas here is getting free points. Because, again, if we read this question, the demand for labor, that's the marginal revenue product. If the market price of the product, P, increases, well, uh, the demand curve will increase because marginal revenue product is the demand curve, and marginal revenue product is equal to the marginal product times price, and the price of the output. And so if the price out is of the output increases, then the marginal revenue product increases, which means the demand curve has increased. So, we'll just say increase. And it says explain, and you have to, so it would basically say something like that. The demand curve is the marginal revenue product, which is equal to marginal product times price. And if the price increases, the marginal revenue product increases. So the demand curve increases. Thank you for your time.